Welcome back to my YouTube channel once again. Today we will try to cover the state observer. The concept we will today develop or we will try to establish the concept of a state observer, right? In the series of the modern control system. So we already have developed the concept of the pole placement design, and we have designed the controller, feedback controller using the Ackerman in the previous video, and before that we have already designed the controller using the transformation into the CCF controller control form, and in the previous we also have developed the concept to design the controller, feedback controller using the method of matching coefficients. So these are the three methods: method of matching coefficients, controllable canonical form transformation, and Ackerman. With the help of these three concepts, you can design the controller, feedback controller, and you can find out the gain matrix K. Okay, but as you know that the when you are going to apply this theorem, first of all you have to ensure that the your system should be the completely controllable. Completely controllable means the feedback, all the feedback, all the states variables are available at the feedback. Completely controllable means we are assuming that in the pole placement design, you can say that in the pole placement design, in pole placement design, in pole placement techniques, you can for designing the controller, for designing the controller, for designing the controller, it was assumed that it was assumed that all states all states variable all state variables are available at feedback, so it's a first concept. It is the very first concept we have seen already. Okay, so in the pole placement technique for designing the feedback controller, it was assumed that all state variables are available for the feedback since the system is completely controllable. All you want to say it. So it means what happened in the practical problem. In the real-time problem, you can say, however, all the state, all the state variables, variables, right, may not be available, Why? May not be available for feedback, right? For feedback. Why? Because, or you can say it is impractical. It is also, it is impractical. It is impractical to measure, to measure the state variables, for the state variables of, you can say, you are not able to measure all the state variables. Okay, so let's say we have this such type of, we have one type of system where you are not able to measure any of the states due to certain regions, due to the complexity, due to the complex cause, due to the accuracy. In such cases, it is estimate. It is in such cases. In such cases, it is necessary to estimate. It is necessary. It is necessary to state estimate. Sorry, estimate the state which is not, which is, yeah, which are not unavailable or non-available, which are unavailable Unavailable means that is not able to measure. Okay. So in that such type of system, such type of state, you have to estimate. You have to estimate that state. They are not that are not able to, you can say, the measure, right? Because the you know the because in order to design the controller, you need all these states as you have assumed. So those who are not able to measure, there's those states which are not able to measure, you have to estimate and send to the in order to design that controller. So you can write here estimated estimated state variable state variables estimated state variables rather than actual rather than actual states are then fed to controller, right? Fed to controller, because the real time of that states are not available, and then we have to estimate that state variables, and these state variables, rather than an actual value, rather than an actual measurement, we have to send this estimated variables to the controller in order to design. Okay, the fundamental is this one. So it means estimation of unmeasurable state variable, simple funda, state variable. Ultimately you are going to measure those state variables which are not able to measure, right? So estimation of measurable state variables is is known as observation, is known as observation. This is the funda. Okay, so this is the concept of observation. And now the another term, that is, you can say, the observer. What means observer? Observer means estimation. The observer or the estimator you can say, is a nothing but a subsystem, is a subsystem, right? Subsystem that reconstruct the state of plant, that reconstruct reconstruct the state of plant, state of plant, right? So this is a concept. It means those state which are not measurable, you are going to estimate, and that estimation of unmeasurable is called observation. The observation of the estimator is a subsystem. Simply, it is a subsystem which is nothing but the reconstructing. You are going to reconstruct the state of plant, right, with the help of some concept. Okay. So once, let's say, if you are able to, you can say, the full order state observer. Now we are going to define, if, let's say, if a state observer, if a state observer observes observes or estimate all state variable, all state variables. Let's say any system that observer, all estimator, that estimates all the state variables, even if some state variable, if some, sorry, state variables are available for direct measurement, for direct measurement, it is called, it is called, you know, full order state observer, observer, right? So if a state observer observes all the states variable, even if some of the state may be available, may not be available, but it estimates all the states of the system, then you can say it is the full order observer. Okay, and let's say if the state observer estimates only some non-measurable state variable, such type of system is known as a reduced order observer. Reduced order observer. I don't know why it is not working very good. Reduced order observer, and it is nothing but it estimates. Wait a minute. Okay, it estimates. You know, I don't know what happened to it. Wait a second.